When it comes to the global race for artificial intelligence, there is one absolute bottleneck: raw computing power. To lock in Western dominance, the US government placed strict export controls on high-end NVIDIA chips, deliberately cutting off the hardware supply chain. The industry consensus was clear. Without the ability to buy massive clusters of these advanced chips, foreign labs would be permanently stuck a generation behind American models. Global tech supremacy was supposed to be secured by this physical chokehold. But a software workaround just broke the logic of that strategy. In July 2026, a Beijing-based startup named Moonshot AI, backed by nearly $1 billion from Alibaba, released a new model called Kimi K3. This is a massive 2.8 trillion parameter system aimed directly at the capabilities of top-tier US models like Claude Fable 5. This chart maps the trajectory of AI capabilities between the US and China. According to Bloomberg Intelligence, K3's release collapsed the performance shortfall between the two nations to a mere 6%. This raises a specific technical question. How does a lab build a model at this scale while legally blocked from buying the hardware used to train its competitors? The answer lies in a software framework known as a sparse mixture of experts, or MOE. Looking at K3's architecture, it isn't one monolithic brain firing at once. Instead, the model fractures into 896 specialized subnetworks called experts. When prompted, a router evaluates the text token by token. Out of 896 experts, it activates only 16. In practice, only about 1.8% of those 2.8 trillion parameters are doing compute work at any given moment. The US export controls changed the engineering problem. Labs are moving away from brute force hardware scaling toward hyper-efficient software architectures. Moonshot is now weaponizing that low compute overhead to launch an aggressive price war. At $15 per 1 million output tokens, K3 operates at a fraction of the cost of its top-tier American competitors. You can see the strategy on this cost-to-value matrix. K3 sits in a uniquely disruptive position, offering frontier intelligence at a fraction of the traditional premium price. The macro threat to Western labs isn't that K3 is definitively the smartest AI on the planet. It's that it threatens to turn high-end intelligence into a cheap global commodity. To see what this model can actually do in practice, we have to look past the marketing claims and audit the verified benchmarks. This scorecard shows independent evaluations of K3. The reality is that K3 is not the undisputed general AI king, scoring a 57.1 on the Artificial Analysis Index, which places it third or fourth overall. What it does exhibit is extreme, lopsided utility. This radar chart shows K3 dominating completely in specific enterprise niches like deep research and long-term agentic coding, while lagging in general text tasks. K3 functions as a precision tool for specific enterprise workflows. It lacks the general-purpose reliability found in high-tier American models. Then there is the massive promise of open weights. Moonshot claims absolutely anyone can download K3 and run it locally. This schematic visualizes the harsh math of hosting a 2.8 trillion parameter model. Just holding the weights requires 1.5 terabytes of memory. To actually run it, you need a multi-million-dollar supernode. Here, open only applies to hyperscalers and nation-states. And there is a behavioral flaw hidden beneath its speed. Moonshot acknowledges the model is highly proactive, which has pushed its hallucination rate to an alarming 51% during long-duration tasks. Hardware restrictions shaped K3's architecture and how it is deployed. The ability to build frontier-class models is no longer exclusive to the organizations that own the largest chip clusters.